All right, here we go. We are doing 2.4 today. 2.4, we are discussing real zeros. Whoops, helps if I can spell it right. Real zeros of a function. So 2.4 is all about the real zeros. So you can imagine, hint, hint, what 2.5 is about. Yeah, the imaginary or complex ones. So we're going to work with 2.4 for several days. Make sure we got those before we add on to it, even though it's all stuff we did last year, right? Okay, so to find our real zeros, we need to talk about dividing polynomials. We have three methods we can divide by. We have synthetic, we have long, and then we had the box. All right. Synthetic works anytime you can get a zero. Works when you have a zero. Which means you had a binomial like x plus 2 or x minus 3 that you were dividing by. You set it equal to 0 and you have a number, right? Long division, however, works all the time. And so anytime you're dividing by more than a binomial, guess what you have to use? Oh, you're going to actually use long. You guys told me last year you didn't like the box.
I enjoy the box. Not the box that we're talking about. Not the two lines.
Okay. So, hey guys. So, long division. Anytime we're dividing by a polynomial bigger than a binomial, we are going to have to use long division or the box. Now, you guys told me last year you didn't like the box, but I'm more than happy to do it in either method. Okay. Yes. Okay. All right, so let's first start by talking about long division. I want to remind you about long division because, of course, that always works, so it's always good to have in our toolbox. Yes, very good, Alyssa. All right, long division. What you are dividing by is always going to go on the outside. So let's say I have something as wonderful as the, let's say this. I have x to the third plus 2x squared minus 7x plus 1, and I'm going to divide by, we're going to start off easy with a binomial because we can use it on anything, right? And let's go with x minus 1. We're going to divide by x minus 1. All right, so the first thing we do is this piece gets to go inside the house, as you guys call it. All right, so we have x to the third plus 2x squared minus 7x plus 1. If one of those spots was missing, we had to put a placeholder, right? Okay, then we're going to divide by x minus 1. So here, what times x is going to give us x to the third? X squared. We put it above the x squared. X squared times x is x to the third. X squared times negative 1 is negative 1x squared. This is where we said, when you do long division, you subtract. So what we're going to do is we're going to draw our line, and since we're subtracting, we're going to change our signs. So now x to the third and negative x to the third, they cancel out. I have 2x squared, and 1x squared is 3x squared. Just like in long division, we're going to bring down minus 7x. All right. What times x is going to give me 3x squared? So plus 3x. Now we multiply, just like in long division. 3x times x is 3x squared. 3x times negative 1 is negative 3x. Draw your line, change your signs. Now we add them together. The 3x squared and the negative 3x squared, they cancel. Negative 7x and positive 3x is negative 4x. Bring down plus 1. All right, what times negative 4x, or what times x is going to give us negative 4x? Negative 4. All right, negative 4 times x is negative 4x. Negative 4 times negative 1, positive 4. We're going to draw our line, change our signs. Our negative 4x and our positive 4x, they cancel. I have 1 minus 4 is negative 3. What is negative 3? The remainder. All right, now, last year, I just had you put in R for remainder and then negative 3. Yeah, we got to step it up a little, okay? So, we do. Just like when you do long division, you would take that remainder and put it over what you divided by. We're going to do the same thing here. We're going to take our remainder, negative 3, or put it over what we're dividing by of x minus 1. This is called a summary statement. All right, so this is what we got plus our remainder over what we divided by. Same thing we do if it was regular long division, right? Seriously. Okay, let's try another one. Do you guys remember doing this, right? Sort of. Does anybody have any questions before we make it harder? Okay. So last year I just said you could put an R and put that number there. Now you're going to do what we call a summary statement, which just means you're going to take this problem right here that we got, take our remainder, and put it over what we divided by. So like when you did regular long division, if you ended up with 1, you had to put it over 1 but what you're dividing by, made yourself a fraction, right? Same thing here. We're just making it a summary statement. Yes. Okay. Now, whether I put plus negative 3 over x minus 1 or you put minus 3 over x minus 1, they're both the same thing, right? So it doesn't matter to me which way you want to write it. They're both the same. Okay? So let's try another one. Here is example number 1, actually. Example 1. And this is 1 through 6. Divide. And write a summary statement. All right, let's go with, how about x to the third plus 2x squared minus 5x minus 4, and let's divide by x squared plus 3x minus 1. That looks like fun, huh? All right, so again, what's listed first goes underneath the house, so to speak. X to the third plus 2x squared minus 5x minus 4. On the outside, I'm going to put this x squared plus 3x minus 1. All right, what times x squared is going to give me x to the third? Just an x, right? Put that above the x. X times x squared is x to the third. X times 3x is 3x squared. And then x times negative 1 is negative 1x. Draw your line, change your signs. If we add these together, the x to the thirds drop out. I have 2x squared and negative 3x squared is negative 1x squared. I have negative 5x plus 1x is negative 4x. And then bring down minus 4. What times x squared will give me negative x squared? Negative 1. Negative 1 times x squared is negative x squared. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is positive 1. Draw your line. Change your signs. We have our x squareds now drop out. Negative 4x plus 3x is negative x. Negative 4 minus 1 is negative 5. Do I have anything else to bring down? So this is my remainder, right? So we're going to go plus negative x minus 5 over x squared plus 3x minus 1. Questions? Okay, so we're doing good? Okay. I'd like to do one with a placeholder. Actually, do you guys, if you're good with long division, let's move back to synthetic. Talk about synthetic. Synthetic. The reason it's called synthetic is because it's another way of dividing that doesn't look like dividing, right? It's fake dividing, so to speak. Remember when we do synthetic, we do a long one-sided tic-tac-toe? Yeah, I call it fake dividing. It's synthetic. We're going to put our coefficients across the top, right? Our 0 on the outside. When we set it up, and we always bring the first one down. Then we multiply and add, right? So here is example number 2. And again, I want you to divide and write a summary statement. All right, so this time, let's go with something that looks like this. Let's say I have 3x to the 4th plus 2x to the 3rd minus 5x squared minus x plus 1. And we're going to divide it by x plus 2. So just because I didn't write it like I wrote the last division, it's still division, right? Even if it's a fraction is nothing more than division. So here, if we're going to use synthetic, we're going to do a long one-sided tic-tac-toe. Across the top of your coefficients, 3, 2, negative 5, negative 1, and 1. On the outside here is what makes this 0. Negative 2, good. All right, so here's our synthetic. Bring the first number down. We multiply. Negative 2 times 3 is negative 6. We add it together. Then we repeat. What? Scroll up to what? To what? Huh? Okay. All right. So then we multiply. Negative 2 times negative 4 is positive 8. Add them together. Negative 2 times 3 is negative 6. We add them together. Negative 2 times negative 7. We add them together. We get 15. All right? So every process, bring the first one down. Multiply, it goes here. We add. Multiply, it goes here. We add. Multiply, it goes there. We add. Multiply, and we add. Right? This last one is our remainder. Whatever's in this last box is the remainder. And remember that our polynomial is 1 less when we divide it, right? So we are going to have 3x to the third, oops, minus 4x squared, right here, plus 3x minus 7, and now we're going to go plus 15 is our remainder over x plus 2. That's the summary statement. You like that one so much better. All right, so questions. You guys need another example of synthetic. Be honest. I'm more than happy to do another one. Do we need another one where we have placeholders or anything? No? Okay. All right. Yeah, just put a 0 in for the placeholder. All right, so that is what you are doing for 7 through 12. I said that, right? All right. I want to talk about the remainder theorem. I don't know if I'm not going to get quite that far yet. Remainder theorem. There's an E in there. All right, the remainder theorem just says that if we have as our factor x minus k, if we plug in k to our function, then the result is the remainder. So if I just want to know what the remainder is, or if it has a remainder, then I can use the remainder theorem. So for example, here is example number 3. Thank you. Example number 3. This is really what you are doing for 13 through 24. No worries. All right, so maybe you're given f of x. F of x equals 2x to the third plus 3x squared minus 7x minus 10. And I want to know where k equals 3. So what that's really saying is I want to know if I divided this by x minus 3, what the remainder would be, right? That is our 0. So you can use synthetic division and put 3 on the outside, or we can just plug it in. So that's what we're going to do. I'm going to plug in 3. I have 2 times 3 to the third plus 3 times 3 squared minus 7 times 3 minus 10. All right, grab your wonderful calculators. So we got 50. What's 50? The remainder. Exactly. This is the remainder. I can't even spell. There we go. Somebody's phone's going off and it's like messing up. All right. So for the first half, it writes it exactly like that where it gives you the k. Okay, so for 13 through 18, it gives you what k is. In 19 through 24, it tells you what you're dividing by and wants to know if it's a factor. How do we know if it's a factor? Right, the remainder will be 0, right? So if I'm dividing by x minus 1 and my remainder is 0, then I'm good. If I have x minus 1, what is my k value? 1, correct. Okay, so you got to find your 0. Let's talk about the last problem. It's not like that. It's not a word problem. Find the factored, let's try that again, factor form. All right, and you're going to be given this. So let's say we have a graph, and it tells you that your original function is f of x equals 5x to the third minus 12x squared minus 23x plus 42. Okay? And it's going to give you a picture. So let me draw a picture up here. All right. And maybe this crosses at exactly -3, exactly at 1, but then it crosses somewhere between 3 and 4. We have to find factored form. So what we're going to do is this 0 where x equals -3, right? That 0, I can divide it to get down to a quadratic. This one where x equals 1, I can then divide it to get down to a binomial, and I will have my factored form. That's all we're doing. So we're going to start with our polynomial, and of course I know you guys, so we're going to do synthetic, right? So right here I have 5x to the third minus 12x squared minus 23x plus 42. All right. Huh? Plug what numbers? Well, hold on. I'm trying to hear Shelby's question. Sorry. Oh, yeah, I'm sorry. I was just writing it down. This is my fault. Yes. Yes. I was writing it down. You're correct. So, in here, let me move this down so that we'll just put the coefficients. Yes, I agree. Yeah, nope, that's fine. There were several people answering for you, and I wanted to make sure I was understanding what your question was. Yes, I shouldn't have wrote that up there like that. All right, so here we go. In here, we want a 5, -12, -23, and 42. Right? On the outside, I'm going to start with -3. So, of course, we bring down 5 first. -3 times 5 is -15. Add them together, we get -27. -3 times 27 is positive. 81. Thank you. I was trying to do it in my head. Adding those together, we get what? Oh, I definitely have the wrong zeros because it's not coming out as a 0. All right, let's try this again. Let's change my little picture up here. Sorry, you guys. Change my picture just ever so slightly. All right? We're going to change it so that it crosses. I apologize. Let's cross this through. We'll cross it through 3. So let me get rid of these. We're going to cross it through 3. I apologize. I'm so sorry. All right. So we're going to say this crosses somewhere between 1 and 2, but it crosses at 3. And over here, on this side, we're going to say it crosses at 2. So we'll just get rid of this little dash right there and say it crosses at 2. Because it definitely isn't coming out right. So I got to fix it. All right, so here's how it works. We have x equals -2 here, and we have x equals 3 here, right? So we're going to start with -2. Are we all okay? We're back on the right track here? Nope, does not. Not at all. So I'm going to bring down 5. -2 times 5 is -10. Adding those together, I get -22. -2 times -22 is positive 44. Adding those together, I get positive 21. -2 times 21 is -42. Adding that together, there's no remainder. Now we're going to do it again in the same one. We're going to draw another line, and this time we're going to use 3. All right, so again, I bring down 5. 3 times 5 is 15. Add them together. We get negative 7. 3 times negative 7 is negative 21. Add them together with no remainder. So what's the factor we have left here? Well, we have 5x minus 7, right? Yep, 5x minus 7. The factor for this one is x minus 3. And the factor for this one was x plus 2. Does it matter what order you write those factors in? No. So that's all I'm asking you to do on the last problem is pull the zeros from the picture, divide twice, it'll get you to your third factor, and that's it. Okay? All right. Yes.
How do you find, so how are we going to have to find K for the...
It's going to tell you it. Well, so there's a section where it says what K is, and there's a section where it says for the factor x minus 1, which is just 1. Okay?